and welcome to my guide for solving literal equations. What is a literal equation? In math, a literal equation is a math problem that has multiple variables. It is often a mathematical or scientific formula. When working with literal equations, our goal is to get one of the variables by itself or isolated. Solving for a variable. To solve for a variable in a literal equation, we need to isolate it, get it by itself. To do this, we must take the other pieces of the equation that are on the same side of the equation as the variable we are solving for and do the opposite operation that is there. So in other words, we're going to look on the same side where the letter we want to get by itself is and move everything else over to the other side of the equation. And we're going to look at a few examples on how we're going to do this. Example number 1. Let's take the formula for the area of a rectangle. So this is a pretty basic formula. You should be very familiar with it. The area formula for a rectangle is area equals base times height. Suppose that the question asked you to solve for h. So we would see that we have a, b, and h. And h is the letter we want to get by itself. So we have to ask ourselves, what's on the same side of this equal sign? If it helps, draw a line and make a wall. And if we look on this side of the equation, the only other thing on that side for this particular problem is a b. And the little asterisk symbolizes multiplication. We could have just written the two letters next to each other. So to get rid of something we're multiplying by, we have to do the opposite operation, which in this case is division. So I'm going to divide by b. But the same rules apply. You've got to do the same thing on both sides. What you do to one side, you do to the other. So I have to divide this by b. Now over here, on this side, all that's left is an h, because those cancel out. Over here we have an a divided by a b. We can't divide. We have no idea what those numbers are. They're not like terms in any way. So we can't simplify. So the final answer is really just a divided by b equals h. And that's all you have to do. So that was a very simple example. So let's go ahead and look at one that's maybe a little bit more complicated. Example number 2. Let's look at an example of a linear equation in standard form. So we have x's and y's. We do have some numbers in this one. You can see numbers in literal equations. The important part about it being a literal equation is if you have multiple variables. And here we do have two different variables. When you only have one type of variable, you can solve for an answer. But when you have two variables and only one equation, you can't solve to get either of those letters by itself just equaling a number. So when we move on to our linear equation and slope unit, you're going to see examples like this. So I thought I'd cover how we use the same skills for literal equations that we use to solve this, because honestly, this is really just a literal equation because it has two variables in it. Suppose you are trying to get y by itself so that you can graph the equation or so that you can use the substitution method. Both of those are reasons that you might move things around in an equation like this to have y or x by itself, typically y. So here's our y right here, and that's the thing we want to get by itself. So we can draw a wall. We can see over here there's a 3 right next to the y, and then we also have a 6x over here. The same rules apply as apply when you're solving regular old equations and you're trying to get the letter by itself. We typically add or subtract first, and then we multiply or divide. We work backwards through our order of operations. So because we're adding 6x here, to get rid of it, we have to subtract 6x. And what we do to one side, we've got to do to the other. So these cancel out, and we have 3y left. Now over here, these two things cannot be combined because this is a regular number and this has a variable in it. So really you just bring them down. It looks a lot like the first problem where we couldn't, exactly fix things. Now remember that this 27 is positive, so when we bring it down here, we add it. I like to put my x term first because typically when we're working with linear equations, we want something with an x plus or minus our other number. We'll talk about that more when we talk about linear equations, but for now, it's just good practice. It is not wrong if you write 27 minus 6x. That's totally fine also. Okay, so with this y, we still have a 3 bothering it. The 3 and the y are right next to each other, so they are multiplying. So we're going to go ahead and divide. But on this side, we can't just divide one of these things. When you're dividing in a literal equation, you have to divide all of these. Okay, so that cancels out. So you're left with y equals, and then you need to do -6 divided by 3, and that's going to give us -2. Okay, so that canceled out to a -2, and then plus 27 divided by 3, which gives us 9. So now we've got an equation that's a lot easier to graph. You also would be set up to use the substitution method if you end up liking that when we do systems of equations in a few months. But there you go. It's a simple example of how you can move things around to get something that maybe is more useful for what you're trying to do. Okay, so example number 3. Let's take the formula for the area of a circle. The formula for that is area equals pi r squared. You've probably seen that before. This one's going to be a little bit more complicated, but it works the same way. We do our inverse operations. Suppose that the question asked you to solve for r. So, works the same way. We can draw a line down the middle, and here's our r. Notice I didn't circle the exponent. The exponent also needs to go away. It works just like a coefficient or number in front of the letter. You need to still get rid of your exponent as well, but we'll get to that in a little bit. So first we have pi, and it's right next to our r. That indicates that we're multiplying. So again, we work backwards through the order of operations, and multiplying, if we're going backwards, comes before exponents. So we're going to go ahead and divide by pi. Okay, so those pi's cancel out, but you can't cancel anything out over here, so we're just going to leave it the way it is. And that's going to equal r squared. Now an exponent is a thing that tells us to multiply something by itself. We want the opposite of that. So instead of multiplying something by itself, we'd want to find out what number times itself. To work backwards, we're looking for something called a square root. And the symbol looks like this, for those of you who maybe have seen it. It has a little like check mark at the bottom. And what we do to one side, we do to the other. So those two cancel out, and that leaves us with the square root of a over pi equals just r. And that's your final answer. If you can understand all of those rules, then if you take your time and work your way through problems, you should be able to isolate anything. I hope this helps. Happy math, guys!